Today, let us talk about functions of two or more independent variables. In this semester, we are going to learn about function calculus of several variables, and we should first try to understand about the difference between a function of two independent variables x and y, or a function of, say, three separate independent variables x, y and z. As we all know that a function of single variable y equal to fx, such as y equal to x, equation of straight line, y equal to x square, equation of parabola, or y equal to sin x, cos x, all these trigonometric functions. We all know about this, the properties of these functions of single variable. Now we would like to extend this idea to functions of two or more variables, two or more independent variables rather. Here z is a function of x and y both. Here u is a function of x, y, z. All these three are independent variables, and u is dependent on these three independent variables. So let us first take an example, a geometric example, to understand about the intricacies we face in defining the limit, continuity and all the related concepts of calculus of a single variable. Let us think about a simple geometric figure of a cone. So we choose the z-axis as the axis of symmetry of the cone, and it is inverted cone, and the origin is the vertex of the cone. So to reach any point on this rim of the cone having coordinate p, x, y, z, we may drop a perpendicular from this p upon the plane XOY plane, which is obviously horizontal. Let us assume that this XOY plane is horizontal and this z is vertical. This is a typical three-dimensional formulation, and this cone, inverted cone, is placed in such a way that the vertex is in the origin and the circular base is parallel to this horizontal plane, so that this z-axis is the axis of symmetry of the cone. Now we drop the perpendicular Pn upon XOY plane from the point P, and then we connect, or rather drop a perpendicular Nm upon this x-axis. So obviously the coordinate of this point specifies that OM is x, NM is y and Pn is z. This is as far as our concept of coordinate geometry is concerned. Now, why do we discuss this, or how this will illuminate us regarding the concept of calculus of two or more independent variables? Let us assume that the equation of this circular rim of the cone is expressed as z equal to function of x, y both. It can easily be written like this: z dependent on x and y both. And to reach this point, we may travel from the origin along x-axis to m, then along parallel path to y-axis, that is mn to n, and then slide up to p along z-axis. Or we may travel from this origin straight away to n and then rise up to p, or we may travel along this guard wall of the cone or boundary wall of the cone to reach P. Just note that while we travel along x-axis, the coordinate x only changes and value of z and y both are 0 along this path. While when we travel along mn, the value of the coordinate x is fixed as small x here along all the path throughout mn. The value of coordinate of p is small x comma y. Y is varying along this path, and z is fixed as 0 because this is in the base plane xy. So all the values along the path of the z is 0 fixed, and values of x coordinates is also fixed x. So y only varies along this path as x only varies along this path, and when we rise up along tree n, only z, the value of z varies, the value of x and y are fixed along this path. So that is the basic concept which takes us to the concept of partial derivative, which is del z del x, same as the ordinary derivative dz dx, where y is kept constant. And similarly, del z del y is treated as dz dy, where x is kept constant. And this can easily be visualized with this picture, isn't it so? Because whenever we are traveling along x-axis from O to M, only x was changing. The value of y and z both were 0. And when you traveled from M to N along this path, only the coordinate of y was changing. The value of x was fixed as small x, and the value of z was 0. And then we travel along NP, where x and y both are fixed, only z varies. So if we can express the equation of the rim of the cone as z equal to fxy, then we can easily comprehend that del z del x is defined to be the partial derivative of z, which is dependent on both x and y. And this partial derivative is same as the ordinary derivative dz dx when y is kept constant, that is along the path OM y. Del z del y is the partial derivative of z, which is dependent on x and y both with respect to y. And this del z del y partial derivative of z with respect to y is same as dz dy ordinary derivative when x is kept constant. So partial derivative is nothing but when we consider one of the two variables as constant and consider the variation of the other variable. Obviously, when you travel along OP, that is the guard wall of the cone, then x and y both varies as with z, and we cannot impose these partial derivatives. Thus, this is a very basic concept to introduce the views of a function z, which is dependent on both x and y as independent variables. Now, we will move on to the definition of a function of two or more variables, their domain, their limit, and their continuity.